Okay, today's lecture is going to be the properties of rational exponents. And we are familiar with all the properties of exponents. The only difference in this one is they're going to be fractions. A ratio, right, is going to be a fraction. So I'm just going to quickly run over a couple of these as an example, and then you can look at them in their book. We're not going to wait to copy all this down. If you need to copy it, it's in your book. But here's an example. The definition of the rules are the same. If I have two bases that are the same, I add the exponents, m plus n, and you can see that in the example they gave, I have a base of 5 to the 1/2 power, base of 5 to the 3/2. The bases are the same, so I simply add the exponents 1/2 plus 3/2. So that's the only difference that we're going to do here, is we're going to be dealing with fractions. For example, if I have one that is a one number divided by another number. So in this case, we're going down to this one where it says 4 to the 5/2 divided by 4 to the 1/2. The largest exponent is the 5/2. So we're going to subtract 5/2 minus 1/2, just like we did on the exponent rules. Like I said, they're just fractions. That's the only thing that's different about these. Okay, and now they're going to cause a problem in a couple days, but right now this is really all we need to know. So let's see how this works. Let's just work some problems on this. Okay, so the first problem I'm going to do is 7 to the 1/4 times 7 to the 1/2 power. Remember now, we do not multiply 7 by 7. The rule says that if the bases are the same, you simply add the exponents. So I'm simply going to add the exponents together. So that's 7 to the 1/4 plus 1/2, and of course we have to have a common denominator. So that's 7 to the 1/4 plus 2/4. That's 7 to the 3/4. Okay. Next one is I have 6 to the 1/2 times 4 to the 1/3. Now these two bases are not the same. So you cannot multiply 6 times 4. Remember, up here we did not multiply 7 times 7 and say, okay, that's 49 to the 3/4. We didn't multiply the bases together, and we're not going to here. So this 6 to the 1/2 and that 4 to the 1/3 will not combine. They are separate bases. And the exponents are different. So what this would be is this is going to be equal to 6 to the 1/2 times 2 times 4 to the 1/3 times 2, which is going to be 6 to the 2 over 2, that's 1, and 4 times 4 to the 2/3, and that's as simple as that will get. Okay, the next one. Now I could actually work this one of two ways. One way that I could work this is I could simply say, okay, let's take the negative 1/5 exponent and distribute it to the 4. So that's 4 to the 5 times a negative 1/5 times 3, 5 times to the negative 1/5, because the bases are not the same. That would give me 4 to the negative 1 all over 3 to the negative 1, which is 1 over 4 times 3, which is 1/12. So that's one way I could have worked that. Now another way I could work this is I could say, wait a second, these both have the same exponent, right? The 5s are the same. So I actually could combine those to the same exponent, kind of working when we distribute the exponent in reverse. So I could have said this as, hey, how about this 4 times 3 to the 5th power? And of course that then would be to the negative 1/5. So because they have the same exponent, they can actually combine inside of parentheses like this. And then that would give me 12 to the 5th. Let me just write that a little different. 12 to the 5th to the negative 1/5. That would be 12 to the negative 1, which is 1 over 12. So in the case where I had the same exponents, then they could combine inside parentheses like I did. Next one. Okay, so what we have is the same base. This has an exponent of 1, which is larger than the 1/3. So that's going to be 5 to the 1 minus 1/3. That would be 5 to the 2/3. Okay. Let's go down to the next one. Now I know we're going to want to distribute this 2 in. I could say 42 to the 2/3, 6 to the 2/3. But if I wait just a second and see if there's a simpler way to simplify it, I can see that these both have the same exponent of 1/3. So I can combine those together with the same exponent. So what I will do, this is the simplest way to work this. I would say, wait, that's 42 all over 6 to the 1/3 because they both have the same exponent. And of course, then that is squared. Well, now 42 divided by 6 is 7. So if my denominator can divide into the numerator and they have the same exponent, it's probably easier for me to combine them and give them the same exponent like I did right there. That's probably the simplest way to work it. So I've got 7 to the 1/3 squared be 7 to the 2/3. That would be the simplest way. Over here, I have the same base, so the exponents add. That'd be 13 to the 1/3 plus 1/6. So let's give them a common denominator. That would be 13 to the 2/6 plus 1/6, 13 to the 3/6, 13 to the 1/2. Moving down to G. I do not have the same base. I do not have the same exponents. Those will not combine at all. So I'm going to have 5 to the 5 times the 1/5, that's to the 1, times 8 to the 5 times the 1/4 power on the 8 would be 5/4. And that would have to stay that way. I guess I could get that exponent off the 5. Okay, the next one. What I have is, let's scan what I have here. I could distribute the negative 1/3 in to each of those. But if I look at it, I have the same exponent. So maybe a simpler way to do it on this one would be combine those, like 12 times 9, multiply those together first because they both have a 3 as an exponent. Then take that to the negative 1/3. Now you don't have to do it that way. That's probably just a little simpler. That would be 108. 12 times 9 is 108 cubed to the negative 1/3. That's 108 to the negative 1, 1 over 108. Okay. And the last two, same base. So we can say that's 8 to the 1 minus the 1/9. That'd be 8 to the 8/9. And the last problem before I distribute the 3 in, let's see if I can divide the 8 into the 56 because they both have the same exponent. So they could combine with one exponent. And sure enough, 8 divides into 56 evenly. So this one, it's going to be easier to do that combination, that division like this. So I will have 8 into 56 is 7 to the 1/4 cubed. 7 to the 3/4. Now, that doesn't necessarily have to be the only way you can work it. I just looked at it and said that's probably simpler to get rid of my denominator if I can at the start because they have the same exponent. And that's all there is.